Welcome to this FMSP online revision video. This video is for MEI D1 on the topic of simulation. Now, looking at the specifications for simulation, there are 5 statements of things you're expected to know. You're expected to know how to generate realizations of a discrete, uniformly distributed random variable, and to be able to use random variables to model discrete, non-uniform random variables. What both of these two mean is just that if you've got something that's generating random numbers, it might just be a list of random numbers, it might be a coin, whatever it is, you should be able to use that to simulate occurrences of something occurring randomly in real life that may be happening uniformly. In other words, it's exactly the same probability of each of a number of different events, or it may not be uniform, so the probabilities of different events might be different. We'll have a look at both of these in terms of an exam question in a minute. Based on them then, you should be able to build and use simple models, in other words, use it for real life situations and interpret those results. And lastly, you should know that a single simulation isn't necessarily accurate in terms of predicting what would happen in the long term, and it's better to repeat simulations many times to get a more accurate feeling of how things would pan out if this happened a lot. All of that will make a lot more sense when we've looked at a couple of exam questions. So here's a fairly standard exam question. This is actually section A1, and quite often simulation comes up in section B, so this is shorter than many of the simulation questions are, but it's good in terms of looking at how we use probabilities to model, in this case, a non-uniform distribution. So, going through the question from start to finish, it says John has a standard die in his pocket, i.e. a cube with 6 faces labelled from 1 to 6, in case you were confused by this and didn't realise it was the singular of dice. You're then asked to describe how John can use the die to obtain realizations of the random variable x defined as follows. So he's got a random variable, and you might recognise this type of things if you've also studied stats 1. But then we've got a random variable which can take the values 1, 2 or 3, and the probability of 1 is a half, 2 is a sixth, and 3 is a third, and obviously these should add up to 1, which they do. In part 2, you're asked how John can use the die to obtain realizations of the random variable defined as follows: 1 with probability of quarter, 2 with probability of quarter, 3 with probability of quarter. And then the last part for 2 marks really is testing your understanding of what it means to use a randomly generated number for a situation. And you're told John attempts to use the die to obtain a realization of a uniformly distributed 2-digit random number. He throws the die 20 times. Each time he records 1 less than the number showing. He then adds together his 20 recorded numbers. Criticise John's methodology. So looking at this question straight through, 1 and 2 are fairly standard in terms of the expectations of the sort of thing you're going to be asked. 3 is a bit more complicated in terms of really trying to understand what's going on with this topic of simulation and using random numbers. So let's have a go at the first 2 parts, the fairly straightforward ones then. So for 3 marks here, John's the standard die in his pocket, it's going to score between 1 and 6. How can he use that to obtain realizations of the random variable defined below? Well, you should be able to spot that the probability of a dice landing on any side is 1/6, and all of these fractions can be written as 6. We've basically got 3/6, 1/6 and 2/6. It's then fairly straightforward from here to identify what would happen. So if John rolls a 1 to 3, we can use that to simulate x is 1. If he rolls 4, we can use that to simulate x is 2, and if he rolls 5 to 6, we can use that to simulate x is 3. And the probability of this should be a half, this should be a sixth, and this should be a third. And we're pretty much done there. Fairly standard type question for 3 marks. Part 2, describe how John can use the die to obtain realizations of the random variable y defined by below. And you can see here that these don't equal a 6. This isn't uniform. We've got a half here and quarters. So it's actually going to be useful for us to write all of these over a common denominator. Now we're going to roll the numbers 1 to 6, and we want to associate those with events with these probabilities. Well, the easiest way to do this, and it should be fairly standard if you practice lots of questions like this, is if we ignore 5 and 6, we're then left with 4 equally likely outcomes. If we rolled 5 or 6, we just roll it again. So we associate 2 of the outcomes. So we'll say if John rolls 1 or 2, we'd associate that with x is 1. If he rolls 3, we'll associate that with x is 2. And if he rolls a 4, associate that with x is 3. We want to make it really nice and clear here for the examiner that we are ignoring 5 or 6 and rolling again. And there we see we've got this is going to happen 2 times, this 1 and this 1 out of the 4 possibles when we ignore these, and we do get these probabilities. Right, part 3. Part 3 is a bit more involved and takes a little bit of reading and a little bit of thinking about. John attempts to use the die to obtain a realization of a uniformly distributed 2-digit random number. This means it's going to go from 00 to 99. It's really important, and you should have practiced these things, that in this way of writing things, 03 is a 2-digit random number. He throws the die 20 times. Each time he records one less than the number showing. He then adds together his 20 numbers. Let's have a quick sketch, and I would advise, if you're answering this on the exam paper, to jot this down in the margin. He's going to score between 1 and 6 when he subtracts 1. He's going to score 0 to 5, and he's then going to do that 20 times. Possibly multiplication's not the best symbol to use there. We're not multiplying by 20. We're repeating 20 times. So if he rolled a 1 and scored 0 20 times, he gets 0. If he rolled a 5 each of those times and wrote down all 20 of those, he'd end up with 100. So immediately then I can spot the first flaw, and it's this 2 here is going to suggest that there's 2 problems with what John's doing. So if I roll 5 20 times, that would give me 100, and that's not a 2-digit random number. The other problem is that it's uniformly distributed. We want each of these to be equally likely. Well, to score 0, I'd have to roll 0 each of the 20 times. To score 1, I'd have to roll 0 19 of the times and 2 1 of the times. It could be any of those times. So you can see from that it's going to be incredibly unlikely to score somewhere around the edge here, say 0 to 1, than it is to score a series of numbers that adds up to 50 or 49. So the other comment then is these are not equally distributed. There's lots of combinations that would add up to 50. There's only one combination that would add up to 0. It's 2 marks, and I do have 2 statements here. So let's have a look at how the marks are awarded for this question then. In the first part, it's 3 marks. It's essentially a method mark for trying to allocate these scores appropriately. An accuracy mark if you do have an order of them, so you have 3 and then 2 and then 1. And a second accuracy mark if you associate them correctly, that 3 of them are here, 2 are there and 1's there. It's worth saying we could have said rolls 4 to 6 here, and rolls 3 and rolls 1 and 2. As long as we had 3 outcomes here, 1 there and 2 there, it would be a correct answer. Now that is correct and it would get you the full marks, but we'll see in the next question that it's often easiest to go for the most conventional approach and make it easy for the examiner to mark. In the second one here, again, there's a method mark for any evidence that you're ignoring something. There's an accuracy mark for saying that there's 2 values to ignore, and a further accuracy mark for getting 2 outcomes here, 1 outcome there and 1 outcome there. And finally, it's just a straightforward mark for this criticism and a mark for this criticism. So that's a shorter section A type question on simulation. Let's have a look at a longer section B question, and one that involves a bit more modelling and interpreting the result that comes out there. So this is quite a long question. We'll go through it quickly and then take a look at each part individually. There's 6 apples on a tree, and each day each remaining apple has a probability of a third of falling off. You're asked to give a rule for using 1-digit random numbers to simulate this for 3 marks. Use the random digits in your answer book, so you are often given random digits to use for this, to simulate how many apples fall off a tree during day 1 and give the total number of apples, 4 marks. Then continue your simulation from the end of day 1 for successive days until there are no apples left on the tree. Use the same list of random digits, continuing from where you left off in part 2. And you're asked during which day does the last apple fall from the tree. In part 4, you're told, suppose that at the start of each day the gardener picks 1 apple from the tree and eats it, and asked to repeat your simulation with the gardener picking the lowest numbered apple remaining on the tree at the start of each day. Give the day during which the last apple falls or is picked, using the same string of random digits, a copy of which is provided for use in this part of the question. And finally, 1 mark, how could your results be made more reliable? Now, if you've done quite a few practice papers, this longer section B type question should look a familiar sort of structure. The key thing with these is to really read the question clearly. A lot of what you're going to do here is just following instructions, following the algorithm really precisely. So, we're told an apple tree has 6 apples left on it. Each day, each remaining apple has a probability of a third of falling off the tree during the day. Give a rule for using 1-digit random numbers, 0 to 9, to simulate whether or not a particular apple falls off the tree during a given day. And we want to generate a third. Well, there's 10 numbers here. If we ignore 1, we'll get 9, which is a multiple of 3. So we can say the first 3 of those, the first third, 0 to 2, is that the apple falls. The next 6, which are 3 to 8, we can get that just by adding 6 on there, is doesn't fall. And again, as we had in the previous question, we need to state the number that we're ignoring. You could here, and it would be perfectly acceptable, do 1 to 3, 4 to 9 and ignore 0. It would be a completely correct answer. I tend to prefer starting at 0, and a lot of the mark schemes start at 0, and a lot of the examiners will expect you to start at 0. So it's perfectly acceptable to say 1 to 3, 4 to 9 and ignore 0, but the convention is to start on 0. So we're then asked to use the random digits given in your answer book to simulate how many apples fall off the tree during day 1 and give the total number of apples that fall during that day, and here's your random digits. Now we're going to use random digits, and I want to cross them out as I'm going along. I don't want to scribble them out completely, I just want to make it clear that I've used them. So we've got our rule: 0 to 2 fall, 3 to 8 doesn't fall, 9 ignore. So we're going to go through now. Our first random number, we ignore 9, we use 1. We use 3, then we use 8, then we use 0, 2, 7. We can then say whether it falls or not, and we can say yes, no, no, yes, yes, no. 3 apples fall. Fairly straightforward if you follow the instructions literally. Part 3. You're asked to continue your simulation for successive days until there's no apples left on the tree. Use the same list of random digits continuing from where you left off. During which day does the last apple fall? We actually got to this 7 here. We've used those in part 1. It's the same list of random digits on your exam paper. I'm just copying them and pasting them across here. So we've then got day 2. The apples that we've got left are apple number 2, 3 and 6. I've got 2, 3 and 6 left. I can do a random number, 0, 1, 4. I can then ask whether it falls, and I've got yes, yes, no. Day 3. Here I've got apple number 6. My random number is 4. Does it fall? No. Day 4. I've still got apple number 6. My random number this time is 8. Does it fall? No. Day 5. I've still got apple number 6. I ignore 9 and use 0. Does it fall? Yes. Let's make this nice and clear now. The last apple falls on day 5. It's fairly clear that I've finished on day 5 there, but there's going to be a mark for this. I'm making absolutely sure I'm getting that mark. Now, last couple of parts. Now suppose an apple has 6 apples left on it each day. Apple probability of a third, that's the same. Now suppose that at the start of each day the gardener picks one apple from the tree and eats it. Repeat your simulation with the gardener picking the lowest numbered apple remaining on the tree at the start of each day. Give the day during which the last apple falls or is picked. Use the same string of random digits, a copy of which is provided for use in this part of the question. It's a new copy in this part of the question, so we're going to start again from the beginning. So, let's have a go through this. Day 1, we've got apple number 1, 2, 3, 4, 5 and 6. We've got a random number and we've got a question as to whether it falls. Now, at the start of day 1, apple 1 is picked. So that's gone. We can then fill in our random numbers. We don't use 9, we use 1, we use 3, 8, 0, 2. Which of these fall? 1 is falling, 3 isn't, 8 isn't, 2 is falling, 0 is falling, 2 is falling. So now I can move on to day 2. Day 2, I'm left with apples numbers 3 and 4. I want to know my random number and whether they fall. Before I do anything, I pick and eat apple 3. So that's gone. And then my random number is 7, so apple 4 doesn't fall. Day 3, I'm just left with apple 4, and that's going to be picked at the start of the day. So what we're asked to do now is give the day during which the last apple falls or is picked, and we can say the last apple is picked on day 4. Finally then, how could your results be made more reliable? This is 1 mark, and this is pretty much always going to be the same response here. We could take more simulations. We could run this again and again with lots of different sets of random numbers and get an average in terms of how many days it took. So let's take a look at the marking for this question. So 3 marks to begin with at the top here. M1 for attempting to use single digit random numbers, an accuracy mark for getting a 1/3, 2/3 split here, and a further accuracy mark for using an efficient version. You could have just said 0 it falls, 1 to 2 it doesn't fall, and ignored 3 to 9, but that really wouldn't be very efficient. So to use 8 out of the 9 is the most efficient to use 9 out of the 10 is the most efficient that we can be here. You could have a convoluted rule, such as say if it's 1, 5 or 8 it falls, and if it's everything else other than 9 it doesn't, and ignore 9. That's fine and it's a correct answer, but you're going to then generate different results based on the random numbers, and you're not making it easy for the examiner to mark. So I would strongly advise going for the most efficient and also the most conventional rule that you can here for these type of exam questions. Over onto this for 4 marks then. There's a method mark for a suitable attempt at using the random numbers. There's then 2 accuracy marks where you lose 1 for each error. So if there's just 1 error, you'd get a 1 here. If you get everything right, you get both the accuracy marks, and then a final mark for this 3. Same here, a method mark for attempting it correctly, 2 accuracy marks for continuing and getting everything right. You would lose 1 if you just had 1 error here, and then a correct mark for saying the last apple falls on day 5. In part 4, again, there's a method mark for applying the simulation correctly, and 2 accuracy marks, again losing 1 for each error that you make, and a final mark here for saying the last apple is picked on day 4. And then finally, as it often is in these questions, there's 1 final mark for saying more simulations. So that ends looking at some exam questions for this topic. As you've seen, being as literal as you can and following the question and the words as closely as you can is what's going to allow you to get the marks here. If you want to see some other revision videos for D1 or other units, please look at the Further Maths website.